Hello friends, in this video we are going to discuss the subject Discrete Time Signal Processing. The subject code is EC8553. In this subject we are going to be discuss 5 chapters such as Unit 1 Discrete Fourier Transform, Unit 2 Infinite Impulse Response Filters, Unit 3 Finite Impulse Response Filters, Unit 4 Finite Word Length Effects, and the last chapter is Unit 5 Introduction to Digital Signal Processors. Okay. In Unit 1, so we are going to be discuss in detail such as first subsection review of signals and systems. So we have already discussed about signals and systems. Even you have studied in your second semester signals and system. The first 2 chapters of signal and systems are very important. Might be you will get questions for 2 marks for your cat 1 exam and also in your main exam. Okay, review of signals and systems, concept of frequency in discrete time signals, summary of analysis and synthesis equation for Fourier transform and discrete time Fourier transform. These things you have studied in your signal and systems. Okay, compulsory you will get 2 mark questions for your cat 1 and also in your main exam. Next, from here onwards the subject of DTSP starts. Frequency domain sampling. Okay, this is also you have studied in your signal systems. Okay, so DFT, this is the actual concept you are going to be studying in the DTSP, discrete time signal processing, discrete Fourier transform. Okay, so derivation and all is not that much important, but equation is very important. Discrete Fourier transform equation and inverse discrete Fourier transform equation. So especially the DFT equation is very important from the exam point of view. Okay, so and properties of DFT, especially this periodicity property is very important in order to solve the problem. Okay, and symmetric property is also important in order to reduce the computational complexity, which means, so if we are not applying symmetric property, which is very especially while solving the matrix based DFT, so that time, so the symmetric property is very important. Okay, the periodicity and symmetric properties are very important. Okay, so might be they will ask for 2 mark question, and also it will be very useful while solving the DFT problem. Okay, especially matrix based DFT problem. And circular convolution also very important. Okay, so this is also one of the property, might be you can get a question, write any 2 properties of DFT. Okay, and next one is linear filtering using DFT. This is also very important question you will for cat 1 and also main exam. Okay, so you have to solve DFT using a linear filtering method. So the next one is filtering long data sequence. So they will give sequence, so you have to solve that sequence using a overlap save method and overlap add method. Okay, for 8 mark question, okay, you will get for 8 mark questions either overlap save method or overlap add method. Okay, they won't ask both the method. Okay, so they will ask either overlap save method or overlap add method. This question is also very very important, okay, from exam point of view. Okay, then fast computation of DFT. Okay, so you have to solve the problem, okay, based on butterfly method. Okay, so there are two techniques are there, radix 2, right, based on decimation in time and decimation in frequency. Might be you will get question, right, you have to solve that, they will ask directly, okay, butterfly method. Okay, then you have to use this method, butterfly method, or if they are not asking the butterfly method, you can solve the problem using a normal linear filtering method. Sometimes they will also ask directly linear filtering method. Okay, and also matrix based method, that is very very, if they are not asking any linear filter, solve the DFT using linear filtering method. Okay, you can use matrix based method to solve the DFT. Okay, that is very very easy, it will consume less time to solve the problem. Okay, otherwise if they are asking directly, you have to solve the problem linear filtering method, you have to apply that method, that technique only. Okay, or if they are asking the butterfly method, means you have to use butterfly method only. Okay, so in the radix 2, so there are again they are dividing decimation in time and decimation in frequency. So the both the methods are different, okay, to solve the radix 2 based DFT, okay, problem. Okay, so we will discuss in the later videos one by one, but from the exam point of view, decimation in time and decimation frequency either are question, might be they will ask in either are basic questions. Okay, so compulsory you will get a question from this, for sometime you will get a question for 10 marks or 12 marks. Okay, and the last uh, the final subsection is fast Fourier transform. It is an advanced version of DFT. It will compute the DFT very fast. That's why they have given name fast Fourier transform. So the last one is linear filtering using FFT. Okay, so compulsory you will get this question also. Okay, again here also you have to solve the problem decimation in time or decimation in frequency. Okay, the unit 2 is infinite impulse response filter. Okay, mm, this is a, it is in this section you are going to be design. Okay, you are going to be design filters, right, the infinite impulse response based filters. Okay, so first you are going to be design analog filters by using a Butterworth and Chebyshev filters. These are the two methods to design the analog filters. Okay, only the equations, the methods, how to design the filters, just the procedure is different from these two methods. Okay, some advantages are there in the Chebyshev filters, okay, when compared to the Butterworth. From the exam point of view, you have to memorize the equation in DTSP. Okay, the equations are very very important. You will get many equations from each unit. So from from the initial itself, while studying first unit itself, just make a note on equations from each subsection. Okay, it will be very very useful from the exam point of view. Okay, so we have to concentrate equations and procedure. Okay, these two are very very important. Might be you will get confused, right, while solving the problem. Then we are going to be design the uh, IIR filters, okay, from analog filters. Okay, I mean, so we are going to design analog filters from infinite impulse response based method, such as low pass filter, high pass filter, band pass filter, band reject filter. Okay, we are going to be design these filters. Okay, especially the low pass filter and high pass filters, these two filters are very very important from the exam point of view. So they may ask design an analog filter using a Chebyshev filter method. So which filter? They will ask the low pass filter. You have to design low pass filter or high pass. Majorly they will ask low pass filter only. So these two filters are very very important. Okay, then we are going to be design digital filters. Okay, by using a um, approximation of derivatives, impulse invariance method, bilinear transformation method. And finally, we are going to be perform frequency transformation, which means so we are not going to be design all the filters, high pass filter, band reject filter. So these are the research topics. Okay, so by using the frequency transformation method, okay, so we can possible to design from low pass filter to high pass. I mean they are transforming. I need high pass filter from low pass filter. Okay, they will transfer low pass filter to high pass filter, low pass filter to band pass filter, low pass filter to band reject filter. So here in this frequency transformation, they have set. There is a set of equations. You have to memorize those equations. So compulsory they will ask to design low pass filter to high pass. Might be you will get this question, okay, for your CAT 2 exams and also in your main exam. Finally, we are going to be discuss the design of or the structure of IIR, infinite impulse response filters, with respect to direct forum 1, direct forum 2, cascade and parallel realization. Okay, so from the exam point of view, direct forum 1 and direct forum 2, these two structures are very very important. Might be there is a possibility to ask cascade and parallel realization of IR filter structures. Okay, unit 3, finite impulse response filters. Okay, so comparatively infinite impulse response filter, there are many advantages in the finite impulse response filter. Might be you will get this question: what are the advantages of finite impulse response filters? Okay, so here also we are going to be design the finite impulse response filters. Okay, um, using a symmetric and anti-symmetric FIR filters. Here, symmetric, we are considering only symmetric type based FIR filters. We are going to be design the FIR filters. Okay, um, using a we have different methods to design the FIR symmetric based FIR filters, such as Fourier series method, okay, and windowing method. So the Fourier series method is also important, windowing method is also important, and frequency sampling method is also important from the exam point of view. Might be you will get questions from Fourier series method, windowing method or frequency sampling method. But according to me, the windowing method is very important from the exam point of view, especially might be again um, in this method there are three techniques are there to design the finite impulse response filter, such as rectangular, hamming, panning, right, panning windows. Okay, especially just these first two methods are very important. Okay, just you have at least you have to understand the concept, procedures, equations, right, and make expertise. You have to make practice more, right, before writing your exam. You have to practice all the problems, okay, 2 to 3 times. That is very important. Here also we are designing the structure, linear phase structure and direct forum realization. We will see this structure is completely different when compared to infinite impulse response filter. We will discuss in the upcoming videos. Unit 4 is finite word length effects. This is very easy, okay, and bit difficult to understand the concept. Where means here the quantization noise, input and output coefficient of quantization error, product quantization error. But just we have to understand the procedure and equations, and as I said before, just you have to maintain one small notes. From that notes, please note all the equations and procedure while before writing the exam. Just uh, look it into that book, okay, notebook, okay, revise the equations, procedure. It will be without any confusion, without any doubts. You can able to answer the questions during the exams. Okay, so in the finite word length effects, so in this section we are going to discuss fixed point, floating point number representation. Here, the floating point number representation is very important from the exam point of view. Okay. Then analog to digital conversion. In this conversion, we are discussing quantization. In this quantization, we are discussing truncation and rounding. These two methods are there to perform the quantization. They will ask which method is better to perform quantization. There is some drawback is there in the truncation method, so rounding method is better than the truncation method. Next one is quantization noise, right? So we will get the noise during quantization. We'll get noise, right? From the original signal, we are quantizing the signal, right? Then we will get a noise. Okay, we will quantizing input and output also, input and output quantization and coefficient quantization error, product quantization error, overflow error, right? So overflow error, limit cycle, overflow error, we will discuss limit cycle oscillation, okay, due to product quantization and summation. In order to overcome this limit cycle oscillation, we have two method. One is a scaling method, okay. mm, Another is a frequency sampling method, okay. So in order to overcome this overflow problems, okay, so compulsory you will get a question from the limit cycle oscillation, okay. And for in theoretical question, for 2 mark question, you will get which are the two methods to overcome the overflow during product quantization and summation, okay. And another question from here, this in either input output or coefficient quantization error, and also usually you will get the question from the product quantization error. Product quantization error, sometimes they will ask coefficient quantization error also, okay. The last chapter is unit 5, Introduction to digital signal processors. So here we are going to be discuss the structure of DSP, digital signal processor. Okay. In this section, we are going to be discuss digital DSP functionalities, circular buffering, DSP architecture, fixed and floating point architecture principles, programming application examples. From the exam point of view, DSP functionality, circular buffering, and DSP architecture. These three subsections are very very important from the exam point of view. Compulsory you will get question circular buffering and DSP architectures for 15 marks. Okay. Um, for DSP, the textbook you have to refer Prokias and Dimitris. Okay, this is a very standard book. So from the you can refer this book. Okay, and also refer Indian author books in order to understand the concept and exam point of view. Chittod and Nagurkan. These two books are very very important. I will upload Chittod and Nagurkani books. Um, just see the description box. There I will upload. Okay. Even I will also upload my notes also while handling each unit. Okay. Thank you very much. Happy learning.